You know, every single day we're handing over our most sensitive information to countless apps and websites. But have you ever stopped to think about what happens when the digital locks protecting all that data are, well, weak? Or even worse, what if they're not there at all? That's exactly what we're going to get into as we dive into the world of cryptographic failures.
And this, right here, just nails it. Imagine writing down your bank details, your private messages, your passwords, all on a postcard and just dropping it in the mail. That is pretty much what a cryptographic failure is in our digital world. It's a total breakdown of privacy where our secrets are just left completely out in the open.
Okay, so there's an official name for this whole mess: cryptographic failure. And it isn't just one single mistake. Nope, it's a whole category of screw-ups. It could mean there's literally no encryption, that's our unsealed letter, or it could mean the encryption is so old and weak that it's super easy to break. And sometimes it even means the key to unlock everything is just left lying around for anyone to find.
So here's our game plan for this explainer. We're going to start with the main problem, then look at how these digital locks actually break. After that, we'll see the devastating impact with a huge real-world example, then learn how to build a stronger shield, and finally, we'll wrap up with why this should matter to every single one of us.
All right, let's dive right in with Section 1, the unsealed digital letter. This gets right to the core of the whole problem. And really, what this all boils down to is information we expect to be private. You know, things like credit card numbers, health records, personal DMs. A cryptographic failure takes all of that private stuff and turns it into an open book, just sitting there for anyone with the right tools and a bit of curiosity. On to Section 2, how digital locks break. So how exactly do these systems fail, right? What are the common mistakes that leave our data just hanging out there so vulnerable?
Well, it usually comes down to four main culprits. We've got unencrypted transmission, using weak algorithms, storing data in what's called plain text, and finally, just plain bad key management. Let's break each of these down.
First up, unencrypted transmission. The difference between HTTP and HTTPS is the perfect way to understand this. Using a site with just HTTP is like shouting your password across a busy coffee shop's Wi-Fi. Anyone listening in can just snatch it right out of the air. But HTTPS, that creates a secure, private tunnel. So even if someone's trying to eavesdrop, all they're going to hear is scrambled, useless garbage.
Next, we have weak algorithms. Man, this one's like locking your front door but using a lock that's made of glass. I mean, sure, it's technically locked, but it's not offering any real protection, is it? Using old hashing methods like MD5 or SHA-1 is exactly like that. Modern computers can literally crack these in seconds, which makes them completely useless for protecting passwords today.
And then there's plain text storage. Honestly, this one is just as bad as it sounds. It means a company stores your password or your credit card number as simple, readable text right in their database. So if a hacker gets in, they don't have to crack a single thing. They just have to read. It's like breaking into a bank vault and finding giant stacks of cash just sitting on the floor, no safes in sight.
And finally, poor key management. This might be the most ironic failure of them all. You could have the strongest, most unbreakable encryption in the entire world, but if you leave the secret key needed to unlock it in a public place, like hard-coded in your app's source code on GitHub, you've accomplished absolutely nothing. It is the digital version of leaving your house key right under the doormat.
Okay, let's move on. Section 3. When a giant fell. We've talked about the theory of how these locks can break. Now let's look at what happens when they fail in the real world, at a terrifyingly massive scale.
This is the question that keeps security professionals up at night. Because when a major organization, one with data on millions and millions of users, gets this wrong, the consequences are just staggering.
147 million. In 2017, that was the number of people whose most sensitive personal data, we're talking names, birth dates, social security numbers, was exposed in the infamous Equifax data breach. This wasn't just some technical glitch. It was a life-altering event for millions, and it was fueled in part by these exact types of failures.
And the fallout from a breach like that is just immense. For individuals, it can mean years of dealing with identity theft and fraud. For the company, it's billions in fines and cleanup costs. And for their reputation, the damage to public trust can be permanent. Seriously, when that digital lock breaks, everybody loses.
All right, that was pretty bleak. So let's move on to something a bit more constructive. Section 4. Forging a stronger shield. After seeing all that damage, it's pretty clear we need better defenses. So what do those look like?
The good news is the solutions are actually well-known and battle-tested. You can think of it like a toolkit for good digital security. First, you always encrypt data while it's moving across the internet. That's called data in transit, and you do that with HTTPS. Second, for passwords, use strong modern algorithms like bcrypt, which are designed to be really slow and tough to crack. Third, encrypt data even when it's just sitting in a database. We call that data at rest. And finally, use professional key management systems to protect your secret keys instead of, leaving them under the digital doormat.
This lays it out perfectly. For every single weakness we've talked about, there's a specific, powerful shield. Instead of sending data in the clear with HTTP, you use the secure tunnel of HTTPS. Instead of a brittle old password hash, you use a modern one like bcrypt. Instead of storing raw data, you encrypt it at rest. And instead of leaving keys in your code, you secure them properly with a dedicated key management system. It's a clear, actionable playbook for security.
So let's bring this all together in our final section, why your data matters. What is the one crucial point we really need to take away from all of this? At the end of the day, this isn't just some abstract problem for developers. It affects every single one of us. Every time you type in a password, buy something online, or send a private message, you are placing your trust in a system to protect that information. You are trusting that the digital envelope is sealed tight.
So I'll just leave you with this question. Our entire digital life, our banking, our communication, our very identities, it's all built on a foundation of these cryptographic locks. We have to ask ourselves and we have to demand that the services we rely on every single day are building them strong enough to actually hold.